In this video, I'll be covering question 6, part C from the 2018 AP Calculus AB free response portion of the test. I cover parts A, B, and C all in their own individual videos, so if you want to see my solutions for A and B, please check out my other videos. Alright, so part C here wants us to find our particular solution of y equals f of x to the given differential equation with the initial condition f of 1 equals 0. So particular solution means we're going to be doing an antiderivative, and that particular solution means we're going to want to find that plus c value that you always get when you're taking antiderivatives. So the given differential equation is this derivative up top here. And then the initial condition, that's an x value and that's a y value. And that's the point we'll use to find our plus c value that we need for our final particular solution. So the way this process works here, so we start with our derivative, dy dx equals 1/3 x times y minus 2 squared. What they call this is a separable differential equation. And usually nowadays on the updated versions of these questions, on the free response questions that I've seen since basically since 2019 through 2023, is they will say using separation of variables. They actually will say what they want you to do nowadays on this, but back on these older exams, they didn't tell you to use separation of variables. They just wanted you to identify that that was your method. And so separation of variables is exactly what it means. We're going to want to get all of our x pieces on one side and all of our y pieces on the other. So I'm going to want to move the dx up out of the bottom and over onto this side. And then I'm going to want to move the y minus 2 squared. Essentially, I'll be multiplying by 1 over y minus 2 squared on both sides to get the y pieces on one side and the x pieces on the other. So if we clean this up now, the dx's cancel out, and so on this side we're looking at 1 over y minus 2 squared dy, and that's going to equal the y minus 2 squareds cancel out, and we're left with just 1/3 x dx. Now that you've got them separated, now is when you essentially put in a little integral symbol, a little antiderivative symbol, and it's like you're doing two integrals at once. We'll go ahead and do the one on the right side real quick because that one just requires us to apply the power rule. So the power rule for antiderivatives, the saying that I use goes add 1 to the power, and then step 2 of that process is divide by the new power. So adding 1 to the power, there's an unwritten 1 on that x. I would add 1 to the power. That's going to get me 1/3 x. Add 1 to the power gets me a 2. Divide by a new power. And then I'm going to put, whenever I take my antiderivatives, I put a plus c. When you've got two integrals, two antiderivatives like this, you only want a singular plus c that counts for the whole equation. And I always recommend putting it on the right-hand side over here. It will just make the algebra later on a heck of a lot easier. So my last move that I would do on this right-hand side is really just combine the 1/3 and the 1/2 here to make this 1/6 x squared plus c. Now when you go looking at the left-hand side is actually going to be a u substitution. If you can get to a point where you can identify these, if you've got 1 over and it's just a constant, like whatever that constant is on something here, really this behaves the same as 1 over y squared, except in the end where you would have a y, you would end up with a y plus 3. So it's kind of, if you can train yourself to recognize this and sort of rewrite that as y to the negative 2 and then do your add 1 to the power, divide by the new power game, you really can then at the end here just go ahead and put that y plus 3 to the negative 1 like I said, you'd only have 1 plus c on this normally. So it's when you just have an addition of a constant that it really can kind of help you skip through a u substitution pretty quickly. That being said, we'll talk through this thing because identifying that, that's kind of like a next level skill. If you've got everything else in your back pocket, go ahead and try working on some of these special cases like this where to identify and make your life a little easier. but at a minimum, we should be able to do a u substitution on this. So we're going to go ahead and run the u substitution process because you may not identify that method. So step one of the u substitution process tells us that we want to choose the u. When I get to choose my u, I've got sort of a priority list that I go through. The first thing that I go looking for is a natural log if it's available. If I don't see a natural log in the problem, the next thing I go looking for is what you would call the inside piece, as if you were doing a chain rule problem. So something inside a set of parentheses. Then if that's not there, the third thing that I go looking for is the bottom of a fraction. And I just sort of work my way down this list until I find one of those things. So starting at the top, there's definitely not a natural log in there, so I'm not going to use that option. Then the second option is an inside piece. And what you can see is for sure this y minus 2 is inside that second power, inside that squared. So my u on this one is going to be y minus 2. Then step 2 of the process, once you've chosen your u, is you want to go ahead and take the derivative. So you're going to take the derivative of both sides. This would be du dy, and you always want to use that differential notation. Du dy, du dx if you're talking x's. And then on this right-hand side, the derivative of y would be 1, and the derivative of negative 2 is the derivative of a constant would go away. When we go to substitute back in, we need this whole left side to be talking nothing but the language of u, and that includes changing out that dy for a du. So the next step of this process is to resolve this derivative here to get dy by itself. On this problem, it's really straightforward. There's not a lot of algebra to do to get dy by itself. We end up really just getting du equals, those cancel out, 1 times dy would get us a dy. So now we'll do the substitution portion of this. We'll take the du and substitute it for dy, and we'll take u and substitute it for y minus 2. So what I always tell people is just kind of work your way left to right through your integral now, and it's either one of the things you're substituting in for, or it sticks around. So here I'm going to have that integral symbol, nothing happened to that 1 on top. On the bottom, instead of y minus 2, I now have u squared, and then instead of dy, I now have du. So that's what I call your reward for all your hard work, a brand new math problem. Remember that the idea behind u substitution is you want to take it from something you didn't know how to take the antiderivative of, and ideally turn it into something you do know how to take the antiderivative of. So looking at 1 over u squared, the first thing that you would want to do on that is a rewrite. So whenever we've got a number over, I always just remember them as x's, my rules. A number over x to a power, we want to rewrite that by bringing the x up from the bottom to the top and making that power negative. So if you had something like 5 over x to the third, you would want to rewrite that as 5x to the negative 3. So the first thing that we'll do here is rewrite this. This will be u to the negative 2 du. From there, we're now ready to go ahead and apply our power rule again. So we would add 1 to the power, divide by the new power, so we get u, adding 1 to the power gets us negative 1 over negative 1. And again, on these separable problems, you only want a single plus c. So because our plus c is on that right-hand side, we leave it alone. And then the last move on that u substitution problem is, remember, you didn't really care about u, you cared about what u was. So we're going to plug back in for our u here. So u was y minus 2 to the negative 1. And then that's really over negative 1 if you want to, equals what we've got going on this side, 1/6 x squared plus c. So we've finished out the u substitution portion of the problem. And then from there, as we start to do algebra, I always tell people, negative exponents are great for doing calculus. They are horrible for doing algebra. And so what you want to do is basically undo this rewrite you just did. So we've got a negative exponent. We want to bring that back down to the bottom and make it positive. So this negative at the bottom here counts for the whole equation. So I would rewrite that as negative 1 over y minus 2, and technically that would be to the first, equals 1/6 x squared plus c. Next move is, let's go ahead and find out what that plus c value is using our point here. So what that's saying is when we plug in x is 1, y is going to be 0. So we'll plug in for y the 0. So we get negative 1 over 0 minus 2 equals 1/6. And instead of x, we'll plug in 1 squared plus c. So on this left-hand side, we have a negative 1 on top over a negative 2 on bottom. So that's going to give us a positive 1/2 equals 1/6 plus c. And then we'll solve for that plus c value. So we will minus 1/6 minus 1/6. And we're going to get c equals 1/2 minus 1/6. You got to find your common denominator, right? So this is really 3/6 minus 1/6. That gets us 2/6 or 1/3. So out of there we get c equals 1/3. We're not done yet. That just found our plus c value. And so from there, what we need to do is take our equation and pop our plus c value into that equation. So we have negative 1 over y minus 2. I don't need anything to the first. I'm going to drop off that to the first power is equal to 1/6 x squared, and then our c value, which is 1/3, now gets plugged in. Then from here, what we're trying to do at this point is we now need to get y by itself. So we're trying to solve this equation to get y by itself. What you would do here is at some point, you just kind of, you start playing around with the algebra. I think one of the slicker ways to handle a problem like this is to really kind of get these things as two fractions. So this would be negative 1 y minus 2. If we can get these to be two fractions equal to each other, we can flip them both at the same time, and that'll get that y up on the top. So on this side here, remember 1/3 was really 2/6. Again, if we find that common denominator, we'd end up with rewriting this piece here. This would be x squared over 6 plus 2 over 6. And again, there's, the algebra on this is where things kind of get messy sometimes. So negative 1 over y minus 2 equals x squared plus 2 over 6, bringing that together as a single fraction. Now that this is a single fraction, what we can do from here is we can flip both fractions. If you've got two fractions set equal to each other, you can flip them both, or you could cross multiply, but that's going to make things a little bit crazier. Here, you flip them both, so I would now have y minus 2 over negative 1 equals 6 over x squared plus 2. That just brought the y up to the top. Remember, you never solve for a variable in the bottom of a fraction, and it's just going to kind of make the rest of the algebra a little bit easier. We'll multiply both sides by negative 1. That'll cancel out there. We get y minus 2. We'll just multiply on top here. Negative 1 times 6 gets us negative 6 over x squared plus 2. And then the last move on this, to get y by itself, you're just going to add 2. You don't even need to bring these fractions together. This would be negative 6 over x squared plus 2 plus 2. And that's going to be our final answer for our y value. That is our particular solution because we found out what our plus c value is. So this one was a big one. There were 5 points out of a total of 9 points you get for all of question 6. 5 of them came on this question here. So you would have gotten 1 point on this from getting your separation of variables just set up. You would have gotten 1 point for getting out both of your antiderivatives correctly, 1 point for each of them. So essentially you'd get 2 points for getting both antiderivatives correct. Then you'd end up getting out another 1 point for getting your plus c value here, and then you would have gotten your last point for getting the final answer. So that would have been a big one on this test. More than half the points for question 6 would have come from part C. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.